So today we're going to go over factoring 10D, factoring using the greatest common factor. 10D, we rewrite polynomial expressions of degree 1 and degree 2 in equivalent forms using the distributive property. Keyword is equivalent. We'll talk about equivalent here in a little bit. Okay, so greatest common factor. We previously used the distributive property to simplify expressions. So before, earlier in the year, we distributed this 2n times the 4n, which gave us the 8n squared. And then we did 2n times 5 to get positive 10n. So now, today, our goal will be to go backwards from this process to help us solve equations. So we're going to start with the 8n squared plus 10n, and then we're going to go backwards, and we're going to end up factoring out the 2n and putting the leftovers on the inside, okay? So for polynomials, the greatest common factor is the largest term that divides evenly into each term. So, for example, when we factor out a number here, So I have this, let's say I started out with this 6x plus 9. I'm looking for the greatest common factor. There's a way in Desmos that we can factor out the greatest common factor. What you would do is you would type in Desmos, you would type GCF and then put parentheses, and then you will put 6 comma 9, and you're going to find out the greatest common factor between 6 and 9. So 3 is my greatest common factor between 6 and 9. So I'll take the 3 out, and then whatever my greatest common factor is, I go ahead and I divide each term by that. So I would have the 6x divided by 3, which gives me the 2x, and then the 9 divided by 3, which gives me the 3. Same thing here, 2x squared plus 14x minus 20. I found the greatest common factor between these three numbers, 2, 14, and 20, which is 2. And then you divide each term by that greatest common factor. So you have 2x squared divided by 2, which is x squared or 1x squared. 14x divided by 2. 14 divided by 2 is 7, and you drop the x. And then negative 20, make sure you pay attention, that's a negative 20 divided by 2 is a negative 10. All right. Also, we'll also factor out a variable. So say, for instance, if you look at this first one here, 3x squared minus 5x, the 3 and the 5 don't have a greatest common factor, but you will notice that they both have x's, okay? And in both of those x's, this one has 2 x's, this one has 1 x. So they both have at least 1 x in common. I can't say they have 2 x's in common, they both have at least 1 x in common. So that 1 x that they have in common, I'm going to put outside for my greatest common factor. Okay, so I put this x in here, and I put this x down here. So when I divide those, that's 3. I automatically drop down to 3. And then notice I have 2 x's down here. And remember, when we divide, we subtract our exponents, right? But the way you can think of it is I have 2 x's down here. If I take away an x, I'm left with the x left over. Okay? Same thing here. The negative 5, there's no number to divide it by, so I just bring it over. And then I have an x up here. If I take away an x, I'm left with no x's left over. So that's why I put that there. Any questions? Notice right here, 3p to the 4th plus 15p cubed minus 20p squared. So in this particular one, 3, 15, and 20, I'm going to check the numbers first, the coefficients first. For 3, 15, and 20, they don't have a greatest common factor greater than 1. So there's not a number greater than 1 that they have in common. But you'll also notice that all 3 of them have a p in common, okay? And you'll notice this one has 4 p's, p to the 4th. This one has 3 p's, p to the 3rd. And this one has 2 p's, p squared. So they all have at least how many p's? They all have at least 2 p's, okay? So that's why I take out the p squared right here. So whatever my greatest common factor is, again, I'm going to divide this by p squared. And then I look at it and say, okay, I have the 3. There's nothing to divide it by, so I'll drop the 3 over here. But then I have 4 p's on top. I'll take away 2 p's. I'm left with p squared. For the next one, 15, there's nothing to divide it by, so I'll bring it over here. I have 3 p's on top. I take away 2 p's. I'm left with 1 p here. The negative 20, there's nothing divided by, so I bring it over here. 2 p's on top. I take away 2 p's. I'm left with no p's, so I don't put a p there. So for the last one, we're going to factor out. Sometimes you have to factor out both. You may have to factor out a number and a variable. So in this case right here, 8n squared plus 10n. If I look at the 8 and the 10, I want to find my greatest common factor. So you can go into Desmos. Again, you can type GCF, parentheses, and then put 8, comma 10. Close parentheses, and it'll give you your greatest common factor. So with 2 being my greatest common factor, they bring out the 2 right here. But then you'll also notice they both have an n, and they both have at least one n. So that's why we put an n also on the outside. So they have 2 as the greatest common factor, and n is also greatest common factor. Now I'm going to divide both of them by 2n. And make sure not to forget the n also with it. So 8 divided by 2 is 4. And then 2 n's, and I take away 1 n, and it leaves me with 1 n. Next term, 10 divided by 2 is 5. I have an n up here. I take away an n. I'm left with no n's. So what you should notice is when finding GCFs of coefficients, which the coefficients are the numbers in front, that means we look for the largest factor. We look for the largest factor. And when finding GCFs of variables or the letters, we look for the smallest exponents. Okay, also down here at the bottom, you see it tells you using Desmos to find the GCF. You may want to put a star there. Okay, you type in GCF and then parentheses, type your first number, comma, second number, comma, and if there's more numbers than that, you just keep typing each number. All right, let's go over a couple. Let's find the greatest common factor between these. So for example 1, I want to find the greatest common factor between 14x squared and 24x. So first I start with 14 and 24. Let's find the greatest common factor between those in Desmos. So when I type in the 14 and 24 in parentheses, in GCF, I get a greatest common factor of 2. Now you'll notice they also have what in common? They have an x in common. They both have at least how many x's? 1 x. Okay, this one only has 1, this one has 2. So I can't say 2, this one only has 1. All right, so 5x squared and 15x. 5 and 15, the greatest common factor was what? Was 5, and then you'll also notice they both have at least how many x's? 1x. So 5x is my greatest common factor. Okay, let's do example 3 together. 4x squared, 18x, and 24. Let's find the greatest common factor. So I'm going to go ahead and type in 4, 18, and 24 in Desmos to find the greatest common factor. So you should get 2 when you type that into Desmos to find the greatest common factor. And then you'll notice these 2 have x's, but this third one doesn't have an x, so I can't put an x with it. So my greatest common factor would just be 2. All right? So 3x squared plus 12x and 27. The greatest common factor between 3, 12, and 27 is 3. And then you'll notice while these 2 have x's, the third one doesn't have an x, so I can't put an x as the greatest common factor. So 3 is just my greatest common factor. 35x squared and 63. So obviously they both don't have x's, so I'm not going to be able to put an x. So I really just need to find the greatest common factor between 35 and 63 in Desmos. Okay, so your greatest common factor, what did y'all get for number 5? Should have gotten just 7 as your greatest common factor. And then for number 6, what did y'all get for that one? Should have gotten 8. So let's go through the steps for factoring using the GCF. So first step is you want to identify the GCF. So we did this problem earlier, 6x squared plus 9x. We found out the greatest common factor was 3x because the greatest common factor between 6 and 9 is 3, and they both have at least 1 x. All right, so that's my greatest common factor. Then you divide each term by the GCF. So we divide the 6x squared by 3x, and we divide 9x by 3x. So now we're going to find the leftovers, what goes inside the parentheses. So 6 divided by 3 is 2, and then you have 2 x's on top. I'll take away x, so I'm left with an x left over. Then for the second one part, a positive 9x. So 9 divided by 3 is a positive 3. Now I have an x, take away an x, and that means I don't have any x's left over. So 2x plus 3 would be my leftovers. So then on that, you write your answer. The greatest common factor goes on the outside. So 3x goes on the outside. And then on the inside, the leftovers, which is 2x plus 3, goes on the inside. And that's how you write your answer. Now, just like we did last class period, you can always check your answer. The way we can check our answer, we type this part right here, the 6x squared plus 9x. 6x squared plus 9x in line 1. And then this 3x, parentheses, 2x plus 3 in line 2. And it should be a matching graph. So let's go ahead and do that. So once you type those two graphs in, you'll notice the graphs should be on top of each other, which means if I click on one or the other, they should be the same graph. That lets me know that I have the correct answer. All right, let's go through a couple examples. So 12m squared minus 36. You'll notice both of them don't have m, so obviously we're not going to have an m as part of our greatest common factor. So let's start with 12 and 36, the greatest common factor between those two. Go ahead and find that. So what'd you get for the greatest common factor between 12 and 36? Should have got 12 as your greatest common factor. Of course, we can't add an m to it, so 12 is just our greatest common factor. That goes on the outside. Now let's find our leftovers. I divide each term by 12. So 12 divided by 12 is 1. And then I have 2 m's on top, none on bottom, so I'm still left with 2 m's. So m squared. Then over here, this is a negative 36. That's a mistake a lot of students make. They forget about the negative. This is a negative 36 divided by 12, and that is a negative 3. All right, let's factor out negative 12x squared plus 16x. I want to find the greatest common factor between the negative 12 and the 16. So 12 and 16, the greatest common factor between those two. So we got 4 as our greatest common factor. Now, the one thing we do have to pay attention to, notice this is a negative in front. Anytime you have that negative in front, you have to put you have to factor out a negative 4. So if negative 4, or if there's a negative sign in the very front, make sure you factor out the negative sign. So I factor out the negative 4, my bad. Then what else do they have in common? They both have at least how many x's? They both have at least one x. Okay? So then I'm going to divide each term by negative 4x. So then let's find our leftovers. Negative 12 divided by negative 4 is a positive 3. And then I have 2 x's on top, take away 1 on bottom. That means I'm left with 1. Next part, 16 divided by negative 4 is a negative 4. Have 1 x on top, take away 1 x on bottom. I'm not left with any x's. Go ahead and try this one on your own. 160p squared minus 112p. Factor out the greatest common factor, then put the leftovers inside the parentheses. All right, what y'all get for when you find the greatest common factor between 160 and 112? Should have got 16, and they both have at least 1p. Then on the inside, I divide this by 16p. So on this one right here, 160 divided by 16, you should have got 10. 2 p's on top, take away 1 on bottom, you're left with a p. Next, negative 112 divided by 16. Got 8? No, that's not 8. 7? 7? Negative 7. So you should have got negative 7. You have 1p on top, 1p don't take away 1p on bottom. You're not left with any p's. I'm going to skip to this problem right here with the 3 terms, 5n squared minus 25n plus 15. Go ahead and try this one. So the greatest common factor, 25, and 15. You should have got a greatest common factor of 5. And then notice I can't put an n because the 15 doesn't have an n. So it's just 5 is the greatest common factor. Now let's find our leftovers on the inside. So I divide each term by 5. First one, 5 divided by 5 was 1. And then I have 2 n's on top, none on bottom, so I didn't have to take away any. The next one is a negative 25 divided by 5, and that is a negative 5. That's a mistake I saw a lot of students make yesterday. And then I have an n on top. I don't have an n on bottom, so there's none to take away, so I leave that in. Then the last one is 15 divided by 5 is a positive 3. Remember, you can also check your answer. You type this in the first line in Desmos, and then the second line in Desmos, you type this in, and the graph should match. 2x minus 7. So 2 and 7, do they have a greatest common factor? Besides 1, of course. No, right? So they don't have a greatest common factor. Notice there's not an x. There's not an x on the 7, so they also don't have an x in common. So this one's pretty much already factored. So, or else you can say not factorable. Now in the homework, again, this is very important because we're going to use this for the next few lessons. And this is pretty much the hardest part about the next few lessons. So if you get this down, then you should pretty much have everything else down. So we're going to complete the diamond problems. The top cell contains the product, which means I multiply to get the top number. And then from the left and right cells, while the bottom number contains the sum. That means I'm going to add up to get the bottom number. So look at the first one, negative 21 and 4. I'm trying to figure out what two numbers multiply to give me negative 21, but add or subtract to give me 4. Now, we're going to look at 21, find our factors of 21. The way we do that, we go into Desmos and we start finding our factors. I say 21 divided by 1. It'll give you 1 and 21. 21 divided by 2. You'll get a decimal, so that's not factorable. Okay, you keep going in, 21 divided by 3, and see what your factors are. Now, you'll look at the top number. Notice the top number is negative, and this is very important right here. Anytime you see that the top number is negative, you're gonna find out which two numbers subtract to give you the bottom number. Okay? So out of 1 and 21 and 3 and 7, which one of those subtract to give me 4? 3 and 7 are going to subtract to give me 4. Now I need to figure out which one I need to make negative. The 3 needs to be a negative, so negative 3 and positive 7 are my two numbers. Okay? So next, let's do the next problem. We're going to find the factors of 8. Obviously, 1 and 8 are factors. Okay? Then 2 and 4 would also be factors. 3 isn't a factor of 8. So now, again, I look at this top number. Since it's negative, that means I'm going to subtract to find the bottom number. So which one of these out of 1 and 8 and 2 and 4 will subtract to give me 2? 2 and 4, okay? So that means in order to get a positive 2, I need to change this 2 to a negative 2. So it'd be a negative 2 and positive 4. We'll add or subtract to give me 2. 4 minus 2. Let's look at the next one. 7. So 1 and 7 pretty much are my only factors of 7, right? But you'll notice we're trying to add, since the 7 is a positive, I want to add up the two numbers to give me a negative 8. How can I change these to where I can add these two and it'll equal a negative 8? Make both of them negative. So negative 1 and negative 7 will add up to give me a negative 8. Go over one last one. So my factors of 40. So 1 and 40 obviously is it. Then you can go into Desmos, divide 40 divided by 2, and you get 20. So 2 and 20 will be it. When you divide by 3, that gives you a decimal. 40 divided by 4 will give you 10. So 4 and 10 are factors. 40 divided by 5. 5 and 8 are factors. 40 divided by 6, you'll get a decimal. 40 divided by 7, you'll get a decimal also. Then you're back to 8. So all these are my factors of 40. So now I need to, if I look at the top number, are we going to add or subtract? We're going to add. Since it's a positive number, that means I'm going to add these two numbers to get the bottom number. Which one of these factors adds up to give me 13? 5 and 8 adds up to give me 13, right? But again, we want to get a negative 13. So what do I need to change those to? Change them both to negative. So negative 5 and negative 8 are my two numbers.